Okay, now let's use Python to solve some real problems. Let's say I want to calculate my final grade. So the way to do it is my base grade times a discount. The discounts depend on how many penalties I have. So for each penalty, I will get 1% off from my base grade, and that will calculate my final grade. So if let's say my base grade is 3.0, and times my let's say I get 1 penalties. So 1 minus 0.01, which is 1%, is equal to 99%, which is 0.99. So that is the discount. So 3. That's my 3.0. That's my grade times the discount. That's my final grade in the case of if I have 1 penalties. So that I print out. So what print does is put whatever here into the console. So if you run it, it will give you the result of the calculation and print it into the console. If I don't do this, they will calculate it, but nothing gonna show up in the console. So that's why I do need to write print here. So now it has my grade. And now I want to know the case if I have 2 penalties or 3 penalties. So what I do is I can copy paste and 2 penalty 98, 3 penalty 97. That is the case when I have 1 penalty, 2 penalty, 3 penalties. So let me calculate it, and that is the case. But here's the thing. Firstly, you are the one who write this code, so you understand what 3.0 represents, what 0.99 means. But if other people come in and read your code, they will like, okay, what the hell is those number even means, right? This is not self-explanatory, right? It can mean anything. 3.0 can mean a price for certain product, right? How the world they're gonna think 3.0 represent grade. And second problem is that let's say I make a mistakes and my base grade is actually not 3.0. My base grade is 2.9. And I was like, now I need to change each single letter then. I need to change here to 3.9, here to 3.9, and here to 3.9. I need to change 3 letter code. In this case was okay, since I have 3 letter code. But imagine that I write 100 letter code that use my grade. If I make 1 change for my grade, I need to go in and change every single one of that, which will be very, very painful. So the way to solve this 2 problem is to add variables. So in this case, grade, that's my variable name, and then assign value 2.9. So what this means is that imagine there is a container. Now I put the data, which is 2.9, into this container, and this container named grade. So whatever I call grade, I use whatever in that container. So it's 2.9 in this container. So if I use grade instead of 2.9, they will understand, okay, I'm actually using 2.9. So that is variable, and then I need to change it here to the variable name. So imagine that at the beginning I use variable grade instead of actually handwriting 2.9. And now I make a mistake again. My grade is actually 3.1. Now it's good because I only need to change 1 line of code, and then the following just gonna take out themselves. They're gonna use whatever in that container, which is 3.1. So now it's changed. That's why it's called variable. Second benefit is now it's much more explanatory, right? Now you know, okay, the first factors is grade, represent grade, because it says grade. While the second one is not as self-explanatory. I don't know what is 0.99. Actually, there is a way to make it a variable, but I will not talk about here. When we talk about loop, I'm gonna talk about that, further explain that. In this case, just remember that when you write variable name, it becomes even more self-explanatory. So even if you only need to write the grade once, calculate the grade stuff once, using once, I still recommend using a variable because it's just more explanatory. Okay, secondly, I want to talk about the rules of making variable names, because you can make it grade, you can use whatever name, you can even use a, right? If you use a here, it still work. If you run it, it still work, right? It gives 3.1 value here. But why we use word grade rather than the word a? Because grade is self-explanatory. A, like, who the hell know what a even means, right? If you, in the case of a, you can still have other benefit that you have for variable, like in this case, reuse the data, but it's not self-explanatory. So the convention is always name the variable that's more self-explanatory. And when you name variable, when you give variable name, there's also something that's mandatory. For example, you can't write number. The first letter cannot be number. It can be second letter. However, and if you want to write some multiple words as a variable, you need space in between. For example, my grade, and I can do underscore grade. So migrate, this represents a space. So this is the way if you want to write multiple words as a variable. There's another convention, is that variable you all use lowercase here. So there's another concept called constants. So variable can change, but constant you better not change because the convention. So here, if you say my grade is 3.1, in line 6 I can change to 2, right? And then whatever following this, whatever following line 6, the grade based on 2. If you run it, this grade based on 2, not 3.1. Although they use the same variable name, so it changed the value in the container. That's why the following change. But whatever above this line 6, it's using the O1 because you define here. So it's changeable. A constant is you better not change. It's not mandatory. You still can change somehow, but it's convention. It's a protocol. You better not change it. So if you're using constant, you need to capitalize everything. I say grade. It's capitalize. Oh, oops. So capitalize, and here it's capitalized. So if you using a constant, it means that this one the following code you will not make a change for that variable. Okay, let's talk about data type. So there are generally 4 data type in Python. So one is called integer. It's the number that has no decimal point. The second one is called float. That's the number that with decimal point. And the third one is Latin word, right? It's called string. And notice that you need to have a quotation mark around the words, because as you can see, when you write code, you have variable names, and those are also words you don't want to confuse with the data type string. That's why you need to add quotation mark to indicate the words, sentences, or letters here are actually string, are actually data, not variable name. But fourth type of data is called Boolean. So it's a type of data that can only has 2 values. It's either true or false, on or off, 0 or 1. So it's 2 values. So in this case, you need to write true or false as a Boolean value. So here, I give you an example. For example, I have a variable name called number. It's 1214. I abbreviate to num, just number. So this number is 1214. Float, the way you write float, it's also pi. It's 3.14. It has something with decimal point, and then a mark. Just remember the quotation mark, and then now you have a Boolean value. Let's say whether I pass the exam. It's pass. That's the variable name. It's pass. It's true. So I write capitalized D, true. It has to be capitalized. If you lowercase it will not make sense. It will show you error. You can't write. You have to write capitalized in order to being recognized as one of the data type. So now it's fine, but there's nothing in the console because you never print out anything. So you can check it out by, let's say, printf. You can check it out, mark whether it's pass. I can print it's pass, but here I can write a comma, and then it's pass. So this is a variable. This is another variable. So comma separate them, and also the comma also add a space in between. For example, in this case, there's a space here. So here, man and is pass. If I do it another line, it would has a line break here. So if I do it like this way, it will break into 2 like this. So that is the way how that's multiple type of data that you can use. Thank you for watching. See you next tutorial.